dear forum, I am very glad to welcome you on the next presentation. And I am very glad to introduce our ongoing activity, the Geochemical Survey of the Arabian Shield. And I'm very glad to share with you the methods, the results, and outlook to mining and mineral exploration. This is the Geochemical Survey of the Arabian Shield, GSA project. Myself, I'm Jordan, the technical partner team leader of the project. I'm a geologist and geochemist, working as a senior scientist for the Finland Geological Survey. Oh, sure, here. Okay, so then a few words to introduce the framework of the project. The full title is High Resolution of Geochemical Survey of the Arabian Shield through stream sediment and heavy mineral concentrate samples in the Kingdom of Saudi Arabia. So the website of this forum already announces this project. Read it here. The Saudi Arabia launched one of the world's largest geochemical and geochemistry surveys. And this is what I would like to share with you on the results and the project. Indeed, this project is big. It spans 6 years from 2021, as you can see on the slide, and it finishes in 2027. The client is the Saudi Geological Survey, who contracted the China Geological Survey. The representatives are over here among the audience. You are welcome. And the technical partner, including the International Geosciences, and then the Geological Survey of Finland, which is my affiliation. So the Geochemistry Survey project is a part of the larger project. The overarching project is called the Regional Geological Survey Program, which has a couple of subcomponents, including geological mapping, the geophysical survey, which was just presented by my colleague, Dr. Fergal Murphy, an hour ago in this session. And then also we have the National Geological Database SUP program, and then the National Core Library, the NCL. The NCL is also presented on this forum in a special boost by my excellent colleague, Dr. Tahir Alem. So the aim of the Geochemical Survey project is to produce high-resolution geochemical maps and geochemical atlas to stimulate mineral exploration and to attract mining investment. And that's why we are here today. So let me guide you through the project, this outstanding project, from the beginning along the procedure of the project implementation. This talk will be technical in order to support and provide good science in the support of mining and mineral exploration in Saudi Arabia. So the Geochemical Survey starts with the field sampling. Sampling design and planning is the first step. So all our activities, including sampling, are guided by manuals, which are guidance documents developed by the survey, later to be published by the Saudi Geological Survey. We hope, we trust, they will become international standards later. At this stage, the sampling planning is based on the 50 quadrangles of 1 to 250,000 map sheets is the sampling design basis. And each quadrangle is subdivided eventually to the 1 to 50,000 map sheets, which cover about 25 by 25 kilometers. And then in each map sheet, 100 stream sediment samples are collected. Further on, and that's why this project is high resolution, because each 50,000 scale map are further subdivided to 10 by 10, 100 subsquares, and each Each cell is the basis for one stream sediment sample collection to represent a catchment for chemical composition, the eroded material from the rock in one sediment sample. And then the quality control is a very important aspect of this database. We believe that this is one of the most quality control geochemistry database currently internationally. So when 2 duplicates per each map sheet is allocated, 2% of duplicate samples control the quality of sampling. Oh, sorry, it's here. So here is actually what's going on. 2.5 kilometer by 2.5 kilometer cell, a low order, first or maximum third order stream is sampled for stream sediment. So this is reality, but these are still excerpts from the manual. And then once the sampling site is selected, then stream samples are collected along a 100-meter stretch, either along the body, the stream, or across as it is appropriate. The project recognizes the different geochemical landscapes of Saudi Arabia, such as the flat plains, the Sabka, the Harrat, and Nafud, and the specific sampling collection procedures are designed for the specific landscapes of the Arabian Shield. These pictures show the Sabka on the top and the Harrat, which is a basaltic volcanic area for sampling a unique landscape here. So this is reality. So this is a 50,000 scale map sheet supplemented with a satellite image for sample design. The black dots are the actual sampling sites, and then with a close lookup, this is how it looks like, the sampling design. This covers more than 86,000, I repeat it, 86,000 sampling locations. So once the sampling points and the sites have been identified, the next step, you have to do the job and go to the field. And that's why we geologists, geochemists, we've done, and this slide guides you through, along the arrows, the field procedure. The sample collection focuses on active stream channels, which represent the freshly eroded rock from mineralizations to the stream sediment sampling site. Then the sieving, the material collected at minimum 3 subsites is sieved to less than 2 millimeters. This is an international standard. And then homogenization is very important for representativity. I told you that quality control is an essential part of this project. And then the sample is quartered in the usual way and then split into two boxes and then labeled properly. Then photo documentation is performed on 86,000 sites throughout the Arabian Shield. And then the CGS, the China Geological Survey Geochem Master app is used for digital field data recording. Then the samples are transported back to the base camp, and then a final field record checking is carried out, as the picture shows on the right. And the final product is shown on this picture. There are 2 splits of the sample. One is for archiving at SGS, the Saudi Geological Survey, and then the other goes to China, to the laboratory of the China Geological Survey. So this is how the samples are collected. This is a special picture because these photographs document the collection of the last sample, the 86,000 whatever hundred of sample collected by the SGS director, and together with CGS and TP, the technical partner. This was a ceremonial event concluding and the sampling. I'm glad to announce that all the samples have been collected. But then this is the sampling processing procedure. Remember that there are 2 splits. One split goes to the archive, the sample archive of the Saudi Geological Survey. However, The other is field processed to arrive to China for the laboratory analysis. And the photos on the right shows the field processing camp in Medina, established by the contractor, and there are further sieving and splitting ongoing to remove the fine alien material from the sediment. So this is on-site processing. Okay, so then the one batch of the samples, the one of the white bottles I just showed you, is archived in the excellent archiving facilities of the Saudi Geological Survey. When arrived, is fundamentally quality controlled, everything is checked, and then in the yellow crates are all coded, and the samples are double sealed, supplied with a QR code for digital reference and retrieval and for further investigation and reference. The other part of the sample is perhaps more exciting because that enters the laboratories. This, in China, at the China Geological Survey, we have a separate manual, a guidance document, which the project follows to carry out the laboratory analysis as well. And here it is. One unique feature of this project is that, as you can see in the periodic table, 76 chemical elements, most of the elements in the periodic table are analyzed. This is unique, has never happened before. The 77 analytes have been ever analyzed in prior geochemical surveys. So this is the laboratory. First, the samples are transported from Saudi Arabia to China, and then they arrive at the Wuhan laboratory of the China Geological Survey, and which is fully accredited according to the ISO standards, who carries out the detailed analysis, including extraction of the chemical elements from the rock, from the sediment, using ICP-MS and XRF and other suitable methods for the chemical analysis of the collected sediments. So here is a bit of insight for the laboratory analysis. So 10 different state-of-the-art laboratory methods are used and adjusted for the most suitable analysis of each chemical analysis. I call your attention to your detection limits, which are also unique in this geochemical survey. These are the lowest, or among the lowest detection limits ever produced for geochemical surveys. So, for example, note that for gold and platinum group elements, the nanogram detection limit. So first criteria, detection limits, all detection limits are below the crustal abundance, which promotes the mineral exploration, because this is how to identify subtle geochemical anomalies in the sediment and in the rock. And then there are other mathematical or statistical criteria set for the detection limit. At least 85–95% of all the samples analyzed must be below measured concentrations below the detection limit. This is a pretty strict requirement for those who understand in the audience. Now, quality assurance and quality control makes this database very solid. For quality control, the accuracy and the precision should be analyzed and studied to make it scientifically solid and applicable for mineral exploration on a solid basis. Just to recall what is accuracy and precision. Accuracy refers to the systematic error, precision is the random error. Both are mathematically measured and tested. For the accuracy assessment, like in any laboratory, reference materials, primary reference materials, standard reference materials you can buy internationally are used, and also the project standard materials are used, which we call the secondary reference materials, representing the actual sediment in the Arabian Shield. And this is compared against the measurements in the laboratory. And then for the precision, the same thing without the details. This is the relative standard deviation. And then those who are familiar with the laboratory exercise would recognize that these are pretty strict requirements. So this is how the data looks like in reality. This is the theory. This is the reality of the data. Here you see the quality control chart for chromium for, I think, at least 2,000 samples. And these are the regular measurements of the standards with the 2 standard deviation, the 3 standard deviation error bar. You can see it's pretty persistent, the quality against both the reference material and the project material. And this slide actually shows here all the analysis for chromium. And these are the measurement, the concentration measurements for the standards. And you can see that why the measurements of the samples are fluctuating, reflecting nature, the measured concentration remains constant, which shows that the measurement is constant and of good quality. So this is the laboratory analysis. Now, for further on quality assurance and quality control, the project uses a balanced or nested design, which is the samples are split to normal and duplicate samples, and both samples are analyzed twice in the laboratory. And here's the quality control charts. So when you compare for chromium again, 2 duplicates, there's a very good match. And then when you compare the 2 laboratory analysis, then you get a very nice quality control. Note this number, the 706 repeated measurements. Myself, in my background, I've never seen so many control samples in any database in my previous career. Here we go. And then finally, an ANOVA analysis of variances is applied. This data design enables to characterize the geological uncertainty, the geological variability, the rock, and then the sampling variance, and then the analytical variance. And according to the reported and checked calculations, all the analysis has satisfied the requirements shown here with red. So this is also quality control, the analysis of variance. Moreover, statistics are also calculated and presented for quality control and assurance for the data. The next step, of course, is then when all the analysis is done, the database is created, then it's a huge Excel table, so the statistics are calculated, which is useful for mineral exploration, and the maps are produced. So let's take a look. Of course, we have a manual. I guess you are already used to this. If you always have a specific manual, will be published at the end of the project. So what maps are produced, which are at the disposal of you right now here? The sample location map, the classified point maps. These are the sampling points classified for concentration for each of the cell element, and then it's a contour map with anomaly delineation. This is what we call the single element geochemical maps. This is the maps. The statistics is here for each element and for each quadrangle. This is a 250,000 scale quadrangle. In the case of chromium, as an example, the statistics are calculated and presented. Moreover, for each rock unit, the statistics are calculated, as you can see in this case for gold. And some of the rock units, such as the green one, shows that tends to have statistically higher gold concentration, promoting mineral exploration. This is how a geochemical map looks like as a close-up. This is already downloadable from the database for chromium. And this to be able to see you more, the 85% threshold of concentration is used in this project as an orientation for delineating or identifying anomalies. Anomalies are numbered, in this case for chromium, and then various statistics are calculated, including the normalized area of productivity, which is an indicator for exploration, a numeric indicator to show the potential for further investigation. And then this data is all put into the Saudi Geological Survey National Geological Database portal, and it's already downloadable. Part of it is already done at these links. So what you can download right now is the field database. It's actually an Excel table, the chemical analysis database, which I just introduced you both. And then right now, around 50,000 samples of data has been uploaded and available at your disposal. And then the same stands for the related maps, which is about exactly 1,550 geochemical maps have been uploaded both in PDF and ArcGIS digital map format. And in terms of reports, the metadata report is available for those who want to understand more how this data was generated and can be used. Capacity building is an important part of the project. It's a big project in terms of expert workshops, seminars, and joint fieldwork, which are shown in these slides, including all the three parties in the field, sample preparation, in front of the computer, and in the meeting rooms. This also shows the capacity building, the strengths of our group. The workshop, this documents the last year 3 weeks workshop shared with international presenters and lecturers from various countries. So this is where we are now. So I want to show you in the last few slides what is ongoing right now and in our project. So on this basis, 2 things are now being produced to give an extra and an outlook to mining and mineral exploration. And this is one item the project is working on, the multi-element anomaly maps and reports. So this is how a multi-element map looks like. There's a predefined set of different deposit types with characteristic geochemistry or characteristic combination of elements which are searched for as a fingerprinting in these maps and databases where they fit. And when they fit, the project identifies anomalies which are also numbered and presented. For example, in this case, this is a chalcophile metals anomaly. You can hear it here, metallogenic element in the red, and the gold anomaly, the yellow. So the green dots show an already active mine. So it verifies that our high-resolution sediment sampling procedure identified an anomaly where a gold mine or gold deposit has been already identified. It's a verification. However, there are other anomalies, just right here and elsewhere in the map, which were not identified. And these are the exciting sites for further exploration and investment. The anomalies come with a lot of data. Later we can talk about the technical details, the element associations, and the ranking based on mathematics and mineral exploration considerations. So this is the multi-element map. The other major activity right now is ongoing is the heavy mineral concentrate. Not only the chemical composition, but the mineralogical composition of the eroded sediment from the rock is analyzed in this project for heavy minerals. We have, of course, a manual for this, a guidance document we follow strictly as a follow-up on the multi-element anomaly maps. And also one piece of recent development that all the manuals, by the way, but this manual particularly, have been tested in the field in orientation surveys. So before starting the actual work, the whole group goes to the field, and then we double-check the manual, its applicability, its scientific consistency against the actual field exercise, which is shown here. And the result of this orientation survey is this. So the HMC manual, the heavy mineral concentrate sampling and production is a complicated issue, but it's very important for mineral exploration. The idea is that about 10,000 sediment samples will be collected for detailed mineralogical analysis where there are multi-element anomalies identified. So this is a follow-up for the identified anomalies to derive more data in terms of information in the mineralogical composition. So against the criteria where you have high concentration in areas based on the single element maps, the large anomaly areas put together as multi-element maps, and mineralization element associations, which I just showed you. In this case, this represents 2/3 of the project. 24 target areas or target areas for HMC sampling have been identified using geology and other background information. So once these sites are identified and the sampling points are defined, this is a sedimentological issue. Those who are geologists here, that where to collect the actual sample is where the heavy mineral can settle and accumulate by nature. This is called a placer deposit in an exploration context. is further has to be elaborated for actual field sampling. And this is what we have done. So for example, in the field reality, when you have a number in your Excel table, so this is behind. So then, for example, small sandbars should be identified by the field crew who are trained. Training, that's why capacity building is a very important part, because 16 groups are working parallel, 16 groups, so they have to be harmonized, finding exactly the same location for all the 10,000 sites, where to collect the HMC and the wet depths, they should pick it up. And that's what we, TP, the technical partners, we are also controlling. So more than 10,000 of such mineral samples will be generated. And this is when the HMC samples are collected, the CGS, the China Geochemical Survey in Medina Base Center, established a heavy mineral concentrate processing plant, which these pictures show the spiral queue. If you are familiar with the mineral processing technologies, but of course this is a laboratory scale setup. This is how the spiral queue and the shaking tables are used to pre-concentrate on the site in the field the heavy minerals. And this picture shows our team working on this site. Sure. So this is my personal slide. Why I believe that our project is so successful is because we have a very good international cooperation hosted by the Saudi Geochemical Survey among the three parties in terms of knowledge exchange and joint interactions, both in the field, in the meeting room, and in various discussions. This was recognized by the Saudi government just 2 weeks ago. The project, actually the whole project, the RGP project, received the prominent grant of an outstanding project. Congratulations. I'm very glad to share this with you. So this is a high-level confirmation that the project is proceeding well. For more information, please feel free to contact those listed here, the project management corresponding to the partners, and for more technical questions and issues, the project implementation leaders of the three parties. Thank you for your attention. Questions?
How is this work different from other countries in the world? Are they surveying things at the same level, and how does it change the confidence levels in the prospects of the minerals?
Thank you very much. Very, very good question. I myself, I've been working for the European Union, actually European Geochemical Atlas, the Forex Geochemical Atlas, and also the GAMAS project, including 26 and 32 European countries, which are actually the United Nations recognize these data sets as the best in the world right now. But for example, answering your question, this most ambitious European Geochemical Survey or mapping program included only 56 chemical elements. This includes 77. And also the density there was 50 kilometers. This is 2.5 kilometers. 2.5 kilometers is, I think, the length of this, the next building here. And this is for the whole Saudi Arabia. So I think this is the second one. So the third is in terms of quality. All these international surveys are quality controlled because they run under the IUGS, the International Union of Geological Union Geochemistry Global Mapping Program, which I'm also contributing myself, and also the CGS Chinese colleagues as well. So they supervise. We also use manuals, the standard procedures for all the steps. So this is, and our project is harmonized with these international standards. However, again, in terms of sampling density and in terms of chemical composition, in addition to the mineralogical composition, is also unique. Geochemical surveys don't include mineralogical analysis normally. Now we have this for 10,000 samples strong. Thank you.
Amazing presentation, amazing information. I just have two questions. First of all, you've taken many as you said, more than 80,000 sample from the surface. Did you go any deep, 1 meter or 2 meters, to verify these results? This is one. Two, when a heavy rain comes, a runoff comes as well. Transporting soil from one place to another. Did you count or did you take this into account when you are verifying the results? Thank you very much.
Very good. The geochemist on board. So then, thank you for your insightful question. So the sampling depth is basically was an issue, and then was an orientation survey, quite an extensive one, before the geochemical. That was 2 years ago, actually. Exactly testing what is the suitable site was more or less clear. Should be a first order, first order stream, which represents the freshly eroded material in close distance, for sure. And it should be an active in sedimentology, with geologists, I guess, in this room. We understand which is active. You can see, that it's really it was impacted. Preferably the last, because we don't have streams in Saudi. That's the thing. So under this climate, these are wadis essentially, exposed to torrential heavy rain, and that's pretty heterogeneous material. So that's why for example, we collect several subsamples to be representative, because one sample couldn't represent, let's say you have a river like this. One sample that represents, thank you for the question, because very heterogeneous. So that's why we collect, actually we collect more than 3, 5, yeah, exactly. So we call 5 exactly recognizing this heterogeneity of the sediment to represent the whole sediment. Okay, so this is the location, but then the depth has been tested on the orientation surveys, and this is how we arrived at different landscapes, such as the Sepka and the Harat and other areas require different depths, different approaches to be adjusted. There are a lot of technical details. I'm available. Also through the contacts, and then feel free to contact for technical. This is always in the manual. But then the depth is just, in principle, the only thing is the depth. We collect surface samples, essentially. It turns out it's representative. But the alien, the airborne sand, gives a lot of dilution, not to mention airborne cross-contamination. So that's the I think the main challenge in this environment, how the alien, the wind-blown sediment deposited over the stream sediment can be eliminated. In a flowing river, you don't have this problem. In Europe, for example, because the water carries out all this, and the sediment is down there. However, in this environment, so that was a big challenge, how we can, so then what we do is that when you go to the site, you remove the surface cover, because we realize that the alien cover is in active channels is thin. That's one thing, and then that's why the pre-processing in the site. There's an extra saving, indeed, to remove saving this fine alien cross-contamination. Thank you. Are there further over there? There is a question over there. The microphone, can we have, please?
Thank you. Do you have any regolith maps of the country? And I'm particularly interested in depth of cover, because geochemistry won't work in areas of deep cover, clearly.
Sure, yeah. Very good. There's no regolith map as such. These projects, remember that geological mapping is also a part of the project. We will deliver such, sort of geological information. So sure. So then, in this arid climate has an advantage in terms there is no vegetation cover. So for the satellite, we took it as an advantage. Coming from Europe, everything is vegetated. Okay, that's one thing. The other thing is that so the rock is more or less bare, and then sure. Sorry, your question as I said.
Yeah, the question, I understand exactly.
There's no soil. There's no soil. Yeah.
Where there's good exposure, it's great. Geochemistry is going to work well. But when there's deep Aeolian sand, it's not going to work so well at all.
I'm sorry. Yeah.
And so maybe the simple question is, do you have a map showing depth of cover?
No.
Okay.
But there is no soil. There is no soil. That's the second. No plant, no soil cover.
Yeah, but it's Aeolian sand.
But the regolith, I understand. Yeah, sure. We have this alien sand, exactly. Everything has price. Thank you for your question. Okay.
Hello, amazing job done. Congratulations. My question is, how did you define the background of elements to define the anomalies in different geological suite?
Sure. Yeah, thank you very much. Yeah, this is essential. So one thing is that, okay, so then the mineralization is represented by an anomaly, which means a positive anomaly, which means a high concentration. So this is one thing. So then, and this also areally confined. However, since this project is very high density, we have billions of samples. This gives us a very good spatial or aerial control on the anomalies. Because when you have let's say a map sheet, you have a chromium, let's say a chromium, anomaly, which is just high concentration. But then we have good spatial control points all around, which has lower concentration. So that's one thing. So that's the spatial control because they have billions of samples. The other thing is the statistics. So this is operational defined 85% percentile. We were testing various percentile levels. Yeah, sure. I mean, it's up to you. So the data is there. Play your own games. So this is 85. That was because the geology and geochemistry is very heterogeneous. If you are familiar with the geology of the Saudi Arabian shale, it's heterogeneous. So then that was one idea what you raised. I think I showed you the statistics for the different rock types, the box spots. Remember the color block spots. So different rock types indeed have different, geochemical background and anomalies. That's a challenge. So, however, this is a regional geochemical survey. So we have to keep the balance, being a survey, and of course still giving useful information for mineral exploration. But this is not a mineral exploration project, to define. That's going to be our next project, perhaps. You are welcome.
Thank you for your presentation. I have a question. What is the timeline for the release or actually fieldwork for the collection of samples in the Asir and Taflith areas?
Sorry, so the data availability for what?
Asir area terrain. So.
In the south. Yeah, actually, it's being released. So actually, right now we have. Yeah, please, Dr. Shi, can you answer this question, please?
Yes, now 60% of the chemical data released by the SGS. So the user can download from the website.
Yeah.
And sorry, for the areas that haven't been covered yet in the Asir, when can we expect those timeline?
Okay. In half a year, something, I guess.
Maybe next year.
Okay, perfect.
Yeah. The next year, yeah. So the answer was next year, yeah, sure.
Thank you. One more question. For the areas where we do already have data, some of the elements are not available on the SGS portal, such as arsenic. Can we expect those to be released at any time?
No, that's the question, not to me. I don't know if any. Yeah, this is. Yeah, please use this context, please. Okay. Yeah, it's a very good point. I haven't mentioned out of the 77 analytes. 20 elements, which are the rarest elements, arsenic, mercury, and uranium and thorium, are confidential elements. So right now you can freely download, after registration, you can download 56 analytes, chemical elements from the website. The other 20, you have to issue a specific request using these contacts.
Perfect. Thank you very much.
Thank you. Thank you for the question, by the way. Okay. And then you can what can you see?
Yeah, just I have a question about I know you've been challenging areas, but my question: how do you collect the samples, maybe in the mountain or in Harrat area?
How it were sampled?
Yeah, how do you collect the samples in Harrat or the mountain,
Yeah, sure. These are a lot of technical questions, because we're running out of time. Please contact, but I can answer. So then the Hara, the problem is that there are no streams, no sediment actually. It is actually regolite, what the colleague already mentioned. So here we are collecting regolith sample. Okay. So there should be a certain size is defined outcrop, and then it's a clear regolith, which is actually a rock fragment. It's not sediment, it's a rock fragment. And this is how we get the Hara sample essentially.
Okay.
Sure.
Is it with the same distance between?
Yeah, I think so. Yeah. This was a year ago. But then, But if you're interested in these details, we are very glad to send an email, and we are very glad to share with all this with
Thank
you.
you.
Yeah.
Thank you.
Thank you. Thank you for your interest. Okay, if there are no more questions, thank you for your attention. We are open to questions later in the coffee break.